2 more seconds. In the meantime, how's your guys' day?
Amazing.
Amazing? Fantastic. Any other responses?
So
you guys all had an amazing day?
It's even better now that we're here.
Woo! Yeah. That's the type of energy we love.
Had to go to lunch hall at 8 a.m.
Lunch hall at 8 a.m.? That's like at least a 50-minute walk from the hill.
It's like 20 minutes. It's so bad.
Yeah. Well, fantastic. Well, we thank you all so much for being here. Let's get right into it.
yes.
All right, so welcome everybody to our SMD soldering workshop. We're your IEEE leads. We'll do introductions in a hot second, but can I have you guys fill out the attendance form real quick? It's just a short little form. Make sure that we count your guys' attendance, and that way we can keep this program running. So keep it on heart. Fantastic. So, everyone get the link? There's also a tiny URL / IEEE SMD if the QR code does. Okay. So, while you guys are filling that out, we'll do a little bit of introductions. So, starting off.
I'm Sanjit, workshops lead this year.
I'm Josh. I'm the other workshops lead. And we're both second-year electrical engineers, so very happy to be here. Alrighty.
Yes, we always take them the day out.
Yeah, this is one of our favorite traditions. We always take a photo like the day out when we're like panicking about the slides, and we're just like, we need to get this done. So, yes, this was earlier today. Alrighty, so a little bit about the learning goals for today. We want to go into the basics of soldering and safety, as well as get an in-depth understanding of SMD soldering. You're also going to be able to practice your own SMD soldering with our very own design boards. So let's get hyped.
All right, so a little bit about what we're going to be doing. So, SMD soldering. Why are we going to be, well, why soldering in general? Like, I don't know, how many of you guys attended the Google workshop? Okay, so a fair chunk of people. So if you attended, so it's like you want to make permanent connections, you want to have like a tiny PCB, something like that. Then you go for soldering. Usually a lot of people opt for Google. Sometimes if you need a really compact board, how many of you guys are in Micromouse?
IEEE project Micromouse.
Okay, so a few of you are in Micromouse. So as Micromouses might know, and if you guys have seen Micromouse before, their boards are really big. They have lots of components and lots of different parts, so then you might want to go SMD on those parts. Yeah.
Fantastic. So let's get into a few of the safety tips. Soldering can be very dangerous, very easily burn yourself. So make sure don't touch any metal parts, especially on the boards that we're going to be soldering tonight that have a metal battery connector. I almost burned myself on that earlier today, so make sure you don't touch that when you're soldering it. Moreover, don't hold the soldering iron any wrong way. Definitely use the handle, and if it starts to heat up, put it down. Organize your workspace. So today, SMD parts are very, very small, on the order of millimeters, so you're going to need to make sure that you keep track of the parts that you're working with, and make sure that you don't lose any. With that being said, we have a few extras, so don't worry if you do lose some, but just make sure that you keep a nice clean workspace. Moreover, solder can be very toxic, so make sure you use your fume exhaust hoods. And after the workshop, before you guys have dinner, or if you guys already have dinner, fantastic, make sure you wash your hands. Okay. Any questions on safety?
Be very careful with the SMD parts because those things fly away, I swear to God.
Yeah.
It's easy to lose them, so very best not to. So some correction tools you might be using. First, we're going to talk about solder wick. So solder wick is basically like copper. The idea is you heat it up. So you heat up the solder wick, you put it on the solder, and what it's going to do is it's just going to suck the solder into the wick itself. So being copper, it kind of attracts the solder, if you will, and it's pretty useful. It actually works a lot better than you might think. So the other thing, solder sucker. You guys have probably seen those in the lab. That's the solder sucker. It's basically a vacuum, so you press down on that thing, you pump it, you press against whatever you're trying to suck, and then you vacuum it. But you need to make sure that it's hot. So let's say you have some joint that you're trying to suck the solder off of. So you heat up the joint, make sure the solder is all liquidy, and then you try to make as tight of a connection as you can with the vacuum pump, and then you suck it up. So yeah.
So here's just a few animations to sort of demonstrate how these tools work. You heat up with the soldering iron, place it as close as you can, then click the button. And then here's the solder wick. You pretty much place the end. I like to fray out the end a little bit. That way it's a little bit easier to stick into the right places. And you just let it melt onto the copper. So we should have a decent amount of these, but if you guys need to share, please do so. And make sure you're courteous when you are soldering. So moving right along to SMD soldering. So first and foremost, we have the components. These are directly mounted on top or bottom of the PCB. They don't cut all the way through, unlike through-hole components. So there are plenty of pros and cons. The pros are that it's more space-saving, but the cons are it's harder to solder. So like today, I was soldering one of these boards for like an hour, just trying to figure out how to get all the tiny components into the right places. So it's very infuriating, but it's a good skill to learn. So be ready. And the contacts of the components sit directly on the pads of the PCB. So you'll guys see it once you guys get your own, but there are little metal pads. Those are where you solder the components to in the end. It's a little bit hard to see here, but those two gold lines on the bottom, those are the pads. And they're either made of silver or a gold alloy. That way they're more conductive.
Yeah, so your SMD components, they'll come in different form factors. For your ICs, you have like SOP, SOIC. For your resistors, capacitors, you have these packages. Okay, those are numbers. What do the numbers mean? So things like 0402 means 4 thousandths of an inch, and 02 2 thousandths of an inch. So once you guys get your things, your components, your passive, your resistors and capacitors, so you'll notice like it's really tiny. The height will be 4 thousandths, and then we're using 0402 today. 0402.
No, I think we're working with like 1206 to give you guys a little bit easier.
Okay.
Anything below like 603, that should be done with like a machine. Otherwise, it's gonna be like trying to. Yeah. So we're taking it easy on you guys.
Okay, so we're using 1206. So again, 12 thousandths of an inch by 6 thousandths of an inch. Yeah. Fairly tiny. Yeah, and then you have your so between like your through hole and your SMD components. So if you guys notice, again, your through hole components are big, your SMD are small. Your SMD components, it's just like, again, like I said earlier, for your PCBs, it's easier to, it makes your board much smaller. So that's something you can use it for. For through hole, again, it's easier to solder. So more or less something like that. Yeah, so sometimes you're gonna, so through-hole soldering is a lot different than SMD, and for SMD, so like we taught you, if you came to the through-hole workshop, we taught you a lot of rules about like what's good practice. Some of them you might follow, some of them you might not. For example, like taking the, heating up the pad before putting on the solder. Sometimes you can get away without doing that on through-hole. For SMD, you kind of can. For the most part, a lot of the good practice you will have to follow while doing SMD soldering. Sometimes you might make mistakes. Sometimes you might use things like your heat gun. So if you do a board wrong, you might use a heat gun to kind of reheat all the solder. You're going to be using a lot of flux to kind of heat up all the pads. I don't know if we is that on a different thumbnail?
I think so. Yeah.
Okay. Yeah. But yeah, there are different ways to kind of do your SMD soldering. Mainly it's heat gun, soldering iron, which is what we're going to be using today, reflow oven for, actually if you're doing 405, so stuff like that.
Yeah. Alrighty. Cool. Okay. So here are a few of the steps to solder. These were a few GIFs or GIFs, however you'd like to pronounce that, found online. Pretty much you apply solder to one corner of the pad, like they do up there. They solder the bottom left-hand corner. And then after that, you match the component to which one you want to solder. And pretty much you heat up that pad and then move the component around with tweezers. Please make sure you're using tweezers because these are going to be very small components and very easily like heatable components. So it could burn you pretty easily. You heat that pad, make sure that your component's touching correctly, and then you solder the adjacent corners. So we'll cover a little bit more on the next slide with IC chips, but pretty much you want to make sure that you solder a few points very carefully first. That way it's set in place before you solder like the majority of them. A good rule of thumb, the 222, I heard about this recently, and I think it's pretty good, is pretty much you heat the pad for 2 seconds, you apply the solder for 2 seconds, you take off the solder, and then you leave the soldering iron on for another 2 seconds. So that way you get a good workflow going of heating the pad, apply solder, stop heating the pad. And then you repeat for the rest of the components and the rest of the pads.
Yeah, so quickly adding on, kind of like you can see here, I think over here what they're doing is are they first applying solder? Yeah, they're first applying solder to the joint, and then they're putting the component on, and then they're heating up the pad again, and then letting the solder kind of liquidify and then kind of form over the pad or the leg once again, right? So other people, some people like to do this different way. Sometimes you put the solder first. Some people they'll take the tweezers, take the part, and then put one leg on with the solder, and then sometimes you might choose to put solder on the tip and then get that out. So there are different ways to do it. You could try experimenting with all of the ways and try to see which one is like the easiest to you. It really depends on the person. But yeah.
Fantastic. So here are a few of the results. So, so here are the few results of SMD soldering. Pretty much this has a good description of how to solder. Once we share the slides with you guys, you can take a more in-depth view. But here are the good results. Pretty much you want to make sure that it's a solid connection sitting right on the PCB, and then that it doesn't basically stick up in the air on a lump of solder. So if you do get this, which happens to me a lot today, what you can do is you can basically stick the soldering iron right here, melt up both the pad and the solder itself, and then basically take tweezers and sort of scrunch it down as it sits down on the PCB board. These ones that we're soldering today, they're pretty small, so you should be able to fit the tweezers around both the board and the component. But if it doesn't, then you might just have to press directly down on top.
The other thing is, if this does happen to you for like the ICs, for like one of the chips, which it did for me, it's going to be nearly impossible to try to take the iron and try to like heat up all the pads and then try to get it to sit down. In that case, I think we have like a heat gun somewhere in the back there, so we'll just use that and then just kind of put a lot of flux, and then you're just going to use the heat gun to kind of heat up all the solder at once, and it's just going to kind of flow on. Yeah. So yeah, kind of again going through the process for ICs again, because ICs are bigger things, bigger components. They're easier to like fall off. So you want to get them solid in by doing two joints first, 2 legs first, and then you can kind of use different. Some people like to do whatever the heck that feels like magic if you've never used flux before, but. Kind of what flux does, and I think we've been throwing the word a lot, but basically what flux does is it kind of prevents you from applying solder on anything that's not the pad. So it's only going to stick to the pad. It's going to make sure that the solder keeps all the nice solder-like properties. So you can kind of see, if you've done through-hole soldering before and you've accidentally like moved your iron too much, you know that this would kind of like solidify between multiple joints. Now that's not going to happen, mainly because you have a lot of flux there. So, yeah.
So just a little side note, sadly we don't have flux for you guys tonight. So what we're going to be doing instead is you're going to have to solder each of the pins individually. So it's a little bit more closer to what is happening up there. where you basically like add solder to 2 of the pins directly. One second, David. Where you add solder to 2 of the pins directly, and then if there is a mistake, which we can cover in the next slide, then you pretty much just heat up that and then sort of break the connection. That transitions well into the. So one of these mistakes that commonly occurs is called bridging, where it's pretty much too much solder applied to a pad and combines 2 of them together. So especially with the ICs that we're going to be soldering today, a lot of pins can be very easily added too much solder to them. So basically what I did to solve it is you basically take a clean soldering iron tip, basically just clean it around in the mesh that comes with the soldering iron. Make sure the tip is clean, and then basically just like sort of cut it like you're cutting butter, and then sort of like drag it out. So that way it creates like two like fine edges. In theory, the solder should attract the clean soldering tip. That's why it removes some of that excess. But if you need more, then you can always use a solder sucker or a solder wick. Yeah. Any questions on that? Yes.
Do you want me to grab the plus from the
I don't know if we have like
Yes.
shareable quantities.
It'll be hard to go around, but I think it just needs to be applied once. So
Okay.
you should probably, that would be awesome. Thank you.
Thank you. Alrighty. What time is it?
It is 23.
Okay,
24.
we have some time. So a quick aside on the soldering iron, sorry, the hot air gun. This is basically if you make mistakes. The next slide.
Oh, yes.
This is basically if you make mistakes or you want to solder like a whole IC chip at once. So how it works is you pretty much, or a little bit more about the hot air gun, is you can basically change the temperature of the air that you're blowing as well as the speed at which you are projecting the air. So it can solder or desolder multiple thin components. If your whole IC chip is wrong, like it was today for me, you basically apply the soldering gun, hold it the tweezers, sorry, the air gun, apply the tweezers, and then after a few seconds, it'll desolder all those components, then you can just take the IC chip right off. So if you make a mistake, definitely be familiar with this one. Few warnings though on safety. It can be deceivingly cold, especially around the handle, and it could be blowing out like 800 plus degrees Fahrenheit. So just make sure you don't point this at anyone, and especially don't point it at your hand, especially when you're soldering. So just be wary, and it's gonna be fun. I promise. I'm making this seem a lot more dangerous than it is. It's gonna be worth it in the end. Yes, just trust. Just trust. So how you use it is you apply solder to each of the pads. You could do this either with a syringe or just a soldering iron to all the pads, and then you basically place the IC chip there, and then make sure you hold it down. Apply the soldering gun, sorry, the hot air gun. Call it a soldering gun, and then you can basically it'll just set right into place. Okay, fantastic.
So, yeah, let's talk about the board.
We're ready. Are you guys ready? Any questions? Okay, fantastic. So let's get right into it. Sanjay, can you walk around with the kids
Yes.
and pass one out?
All
Okay,
right.
so
We're going to give you a kit, everyone.
yeah. Well, I have your guys' attention. Here's the board that we're going to be soldering tonight. Sanjay's going around with kits. All the components are listed here, particularly with the resistors and other elements. Their number combinations are also listed here. Don't worry, you don't have to take a picture. We'll share the slides with you guys. And then, okay, so this is the schematic. And then we have a lot of special notes about this board, just to make sure that this goes smoothly. So the batteries and the microcontroller are separate from the kits. Once you guys have soldered all the other components, come talk to us. We just want to double check the board and make sure that everything's working before we give you guys the final microcontroller and the batteries. Okay. And then, okay, so these notes are pretty much just general tips on how to solder with the board. So you want to do through-hole components first. So on the board, there are a few through-hole components. Specifically, like the 7-segment display, the buzzers, the jumpers, the switches up top. I suggest doing those first. That way they're a little bit easier to get out of the way. And then you try the SMD components. Okay. And then, yes. Okay, a few more things while I have your guys' attention. You want to make sure that you use the tweezers no matter what. The tweezers are available up here. If we happen to run out, please share with your neighbor. And be very careful on the battery holder, it's conductive. And then one last note about the IC chips. So the IC chips, there's going to be a little circle on one of the corners. That indicates which pin is pin number 1. It should be in the upper left-hand corner for both chips. So specifically for like the IC chip, there's got to be a little circle that should go into that corner of the IC chip. Okay? So where these little notches are, that should correspond to the little circle on the IC chip. Yes?
Can you solder the big components?
Yeah, the 2-hole ones, yeah, probably best to save one for them.
Okay, well I did them first, so feel free to experiment as well. And if you guys find that SMD soldering is easier first, then do that. Okay? All right. Any questions? Fantastic. Now, how we're hoping this works is we have extra soldering irons up here, but we also have soldering irons in the room back there. So whoever wants to go back there, first come, first serve, and then we're going to spread out and set up tables on this over here. I think we have enough people that we're going to need to pair share soldering irons. So yeah, we can make it work. We can make it work. Alrighty. What? Alrighty, one last thing. This is the link to the slides. If you guys want to pull up the schematic and other special notes, feel free to do so. The QR code is for the attendance. The tiny URL is for the the tiny URL is for the